Let's solve this question. Now this has got actually a combination of Newton's second law, and you can apply this kinetic friction coefficient of friction to this question, right? Let's see what actually these are the answers. So you can pause it, you can try if you're getting these answers. If not, you can watch the video how to get these. Now, the question says a force of 40 Newton accelerates a 5 kg block at 6 meters per second square along a horizontal surface. So, what are all given to you? The applied force, which is the forward force, it's 40 Newton, and 5 kg block. So, that is the mass of the, looking at the unit, you can make out that is mass is 5 kg and along a horizontal surface, and acceleration. It accelerates, that's a unit here. So A equals 6 meters per second square. So these are all the quantities that are given in the question. Now what's asked first is what would be the block's acceleration if the surface were frictionless? So you don't have to consider any opposing force here. You just take the entire applied forces acting on the object, and there is no opposing force. That's what it means. Frictionless meaning no opposing forces acting on it. So how do we find the acceleration from here? See, ignore this. This is given for, this is the actual acceleration. They're asking you if there is no friction, what would be the acceleration? Okay, so F equals m times a, right? Newton's second, that's why I said you'll be using this formula also in this question. F equals m times a. Here, this F, you take the entire 40 Newton. We are not subtracting anything. You assume that this whole thing is acting on the object. Mass is 5 times acceleration. Okay, so the solution to A. So answer is acceleration will be 40 upon 5. You get 8 meters per second square. That's a unit for acceleration. That's part A. That's a straightforward calculation. Now for part B, how large is the kinetic friction force? So this is a real situation here. See, actually the object is accelerating with 6 meters per second square, not with 8. So there is some opposing, there's something that is slowing it down. There is opposing friction force acting on it. So how do we find that? Now, the net force acting on the object now will be mass of the object multiplied by, again the same formula, but this time we use the acceleration 6, right? 5 times 6, that is 30 Newton. Okay, so the object is having a net force of 30 Newton because that's the actual acceleration, but we need to find out the kinetic friction. Applied force is 40, but 30 Newton is the net force. So what is the opposing force acting on it? The difference between these two, right? So the friction force or the kinetic friction will be equal to 40 minus 30. So 10 Newton is the kinetic friction acting on the object, which makes it slow down. Instead of 8, it's moving with 6 meters per second square. Now part C is use coefficient of kinetic friction. So which symbol is that? Mu k. So they ask you to find mu k. So you know the formula, Fk equals mu k times normal force. So is the normal force given in the question? No. Fk we have just found out here. Normal force is not given. How do we find normal force? Which is also equal to force of gravity, m times g. Right? So 5 times 9.8 will give you the normal force. So you can substitute all this here. Normal force you can substitute, Fk you can substitute, and you can find mu k. So I'll use it here. Mu k equals Fk upon Fn equals 10 upon 5 times 9.8. So Fn I have taken it from here, Fk I have taken it from here. So you get 0.20. If you round it off, that would be the answer that's given here. So we found all three. Hope that's clear. There's a little there's something that you have to think, work it out, and then apply. All right, as I said, Newton's second law is also used here, as well as kinetic friction's formula as well. Hope you understood. Thank you.